Hello, Pre-Calculus 191. I'm going to do this problem for you that is a typical problem that could be on your test. It addresses the issue of holes in the graph, which some of you are asking me about, which is a legitimate question. I'm going to go through asymptotes, the holes, and what this graph would look like. First of all, if we take a look that the degree on the top is less than the degree on the bottom, that means if you follow the horizontal asymptote rules, there will be a horizontal asymptote at y equals 0, which is the x-axis, which would be right here. Well, that was supposed to be on my x-axis. So I have an asymptote that happens right here. If we factor the bottom of this function, if we factor the bottom of this function, we're going to get an x plus 6 on the top. And on the bottom, we'll get an x plus 6 and an x minus 4. This shows that the x plus 6 and x plus 6 on the bottom will cancel out, and I'll get an equivalent equation like this. Now, it seems like there should have been an asymptote at x equals negative 6, but it reduced out. That means at x equals negative 6, there's a hole in this graph. And we'll show you that hole in a minute. But this tells us over here that for x equals 4, 4 minus 4 being 0, where there's a 0 in the denominator, there's a vertical asymptote, and we'll make that one green. It'll be a vertical asymptote at x equals 1, 2, 3, 4. And the asymptote will happen vertically because that's the rule for the vertical asymptote, is where the denominator is equal to 0. Now, this graph is going to hug these two asymptotes. It could be up over here and down here. It could be here and here. It could be both of them being on the top side like this. But in any case, our graph is going to hug these lines without ever touching them or crossing them. So if we just test some values in here, and we can see, well, if I tested a 5 in here, this is going to give me, if you put it into the original one, you'll get an 11 on the top. And then you put it in here, and you'll get a positive value. If you put it in here, you're going to get a 1 over 1. So that means this is going to be the graph over here. At 5, I got 1. It's not down here because it can't cross through. If the point landed up here, then that means that's where the graph is. If I check out x equals 3 in here, I'll get a 1 over negative 1, which is a negative, and that means my graph is here. Oops, I missed that point. So my graph hugs these two lines, and all we need is a sketch or something to look at. Now, what about this point at x equals negative 6, which also makes the original function equal to 0? That means 1, 2, 3, 4, 5, 6. This graph has continued to get closer and closer, and at x equals 6, there's an actual hole in the graph. Now again, where do holes occur? Holes occur for the number that makes the denominator 0, like an asymptote, but it reduced out somehow. So that asymptote actually you could think of as the asymptote reduced out, but it's still undefined at x equals negative 6, and that's why we have a hole in this graph. The only asymptote we have is x equals 4. That's the other value that makes the denominator equal to 0. So the horizontal asymptote is y equals 0. Follow the horizontal asymptote rules. The vertical asymptotes happen where the bottom is 0, where the factor doesn't cross out or reduce out, like this one did. So I hope that helps you understand holes, vertical, and horizontal asymptotes.